excuse me, so the directions on these say 0 to 2 pi. That parentheses means don't include 2 pi. So none of the answers from that section should be 2 pi. If it is that point, you're going to use 0 and not 2 pi. You don't want to include it as part of your answers. So because it's cotangent undefined, that means tangent would be 0. So if you know your circle, right, which you'll get given the original circle, but not the tangent. So maybe I would say at least add a little note to yourself that the over 3 is root 3, that the over 4 is 1, that the over 6 is root 3 over 3. And then tangent on the right, this would be 1, 0. So it would be 0 over 1, which is 0. And at the top would be 0, 1, 1 over 0, and that's undefined. So tangent's undefined at the top and the bottom, and 0 on the right and the left. So if that helps to remember that so you don't have to do the y over x, I would say add that on to your unit circle as soon as you get it. Add this on, add the tangents on, add the quadrants, and I would add the all students take calculus. So that, I think, as soon as you get that unit circle, add those on because it'll help you. Then if I know that tangent is 0, there's 2 places where it's 0, right? And it's at the top and it's at the bottom, and the radian at the top is pi over 2. And tangent, I said the opposite. Tangent is 0 at the right and the left, and the radian at the right is 0 and at the left is pi.
So wouldn't the answer be pi over 2 and...
No, that's if it's undefined. That's if tangent's undefined. This is saying cotangent's undefined, so sine is 0.
Oh.
So sine is 0 on the right and the left, undefined at the top and the bottom. You're welcome. Me exact points, but you want to extend it to give the 2 periods. So the original sine curve is here, right? Then you could go left or right, but you do want to graph one more sine period.
Okay. And you don't have to put
You don't have to put the exact points. So exact points here, 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 here. 5 key points should be exact, and then you're just extending it. Like on this one, the secant was the cosine, right? So the original graph was this part here, right? That was your original cosine. You could have dropped this side, and this side, and then done your asymptotes there and had a curve, a curve, a curve. So as long as you have 1, 2, 3, 4 asymptotes and 3 curves, that's enough. Yeah. So when you do these, like when you're going to do these on your test, what I'm looking for is like your amplitude. I'm looking for the period. I'm looking for the work for the key points. If there's a phase shift, you're going to add it on. And then if there's a vertical shift, you want to identify it. Then you want to draw your graph and then graph it. So like there's lots of space for work on those questions, and that's the kind of work I'm looking for.
Does that drop have to be an exact point?
Does the drop? No. I would just say equally space it out. As long as your 5 key points are given, that's what I'm looking for to be precise. And then for the tangent and cotangent, or tangent, like this one, you need to get me the midpoint. So really there should have been another asymptote here on this and another asymptote here on this. And then you want to find that middle point. So this should be identified, this should be identified, and that should be identified on your x-axis. Yeah.
For number 17.
Fine. So this one was originally sine, right? So it goes this. This is your original curve here, right? Yeah, to the left, pi over 5. Yeah, so that was your original curve. You could either have it continue here and here, or all in one direction. It doesn't matter.
So how would you determine the next point?
So you really just need to eyeball the spacing between the pi over 5 and then the 4 pi over 5. Like whatever that increment is, just give that much space to the other side.
But do we have to mark it?
No. 5 key points have to be exact. Outside of that, no. For sine and cosine, secant and cosecant. Obviously for tangent, I'm looking for the 4 asymptotes to be exact, and then the middle point where the 0 is to be exact. So that is the 4 plus the 3. That's 7 exact points on your tangents.
It's more general question, but like if you're doing a sine or cosine, or like cosine or the opposite of that.
Yeah, cosecant.
You know, phase shift.
Yeah.
It starts where that midpoint is, right? So like if it's sine or cosine, it starts on either the 0 or the y-axis.
Yeah.
And if it's secant or cosine, I mean, yeah, you start on the point. Like the midpoint.
So with the phase shift, you mean?
Yeah.
So let's say the phase shift is to the right, and it's cosine. We'd start up, down, up, up. So it'd start like that. Let's say it's a phase shift to the right, and it's sine. Now we'd start on the 0, up, down, down, up. So it looked like that. If the phase shift was negative, so it went the other way, you just shift it back. So it'd start here. And then if it's cosine, it still starts up. Down, down, up, up. So it'd be like that. And if it was a phase shift left, but it was sine, now you start at the 0, you'd go up, down, up. So still starting at the 0 if it's sine, at the amplitude if it's cosine. Yep. Good turn.
Is there a situation in which a cosine will have started or negative?
I mean, if there's a vertical shift, it could, yeah. If it's, you mean at a negative on the y?
Yeah.
If it's reflected, it's going to start negative on the y. If it was a vertical shift, it could start anywhere. Yeah. Everybody else is good? Okay, this is 23. So with the tangents, you want to identify the A being 4/5 because that's how high-low your quarter and your 3/4 point goes. And then the B would be 2/3. The pi over 2/3 becomes, I keep forgetting the bell's ringing wrong, 3 pi over 2. That's your period. So then I take what's next to the tangent. I set it equal to negative pi over 2 and positive pi over 2. I'm going to solve for x, and I get those are the middle two asymptotes. Those would be these. Then I subtract from what I get the 3 pi over 2. That's the one all the way on the left. I add from what I get to the 3 pi over 2, and that's the one all the way on the right. That's how you get your other side. So don't forget that the period is different. It's pi over b, and don't forget how to add and subtract those.